Hi, nice to meet you. My name is Sri Jorsi, and now I'm about to share some of the materials about derivatives of exponential functions, especially for IB curriculum. Okay, before starting to discuss the derivatives itself, it's better for us to know about the exponential function first. What is exponential functions? Exponential functions is usually written as y equal to ax, while a can also be mentioned as basis. Example, y equal to x, or can be y equal to 5 to x. Here we have the basis, that is 2, and for the second functions we have 5 as the basis. But it's not always a become the basis. It can be also natural number to be the basis of exponential function. And the natural exponential functions can be written as y equal to ex, while e is called Euler number and are equal to 2.7333 and so on, yeah? If we draw the graph of exponential functions, we will have this gotta be x-axis and this one's gonna be y-axis. And the functions of exponentials will be drawn as this one. Okay. It may be called as y equal to ax. The bigger a, the more the graph is gotta be closer to y-axis. So if we have y equal to 2x, it'll be drawn this way. Y equal to 2x. What about 3? It will be getting more closer to y-axis. Y equal to 3x, and so on, yeah? Alright, so that we already know that exponential functions can have the basis at a or e. Now we figure out how is the derivatives of those exponential functions. Before, I would like to draw some tables to make it easier. And ta-da! There was a table. So for the first functions, we have y equal to ax, and we will have its derivatives to be ax ln a, where a is the basis. What about if the power itself is a function? Yeah, so example like y equal to a if x, then it actually just the same but have a bit differences. That is ax ln a times if x and x. This one is actually having an as a if x, yeah? Okay, a if x ln a times if x and x. So besides differentiate the exponential functions, we also have to differentiate the functions of the exponent. The exponent is if x, yeah? Okay, what about if we have a natural number for the basis? We have y equal to ax, and the derivatives of y equal to ax is yxn equal to ex. So what does it mean? It means the functions and its derivative functions is the same for ex. But what about if we have a function of the power? So we have y equal to e of x. It could be shown as y accent equal to e of x times e of x and x. Okay, let's start to look for some example. Number 1, if we have y equal to 3x, what is the dy dx? Okay, first, dy dx means we differentiate y in variable x, in term of x. Since we have y equal to ax, derivatives is ax ln a, then we can figure out the number and answer will be y(n) equal to 3x ln 3, where fx and x can also be mentioned as dy dx. So the dy dx is 3x ln 3. What about the second function? If we have the functions on exponent, like y equal to 5x squared minus x, what is the dy dx? Okay, related to the table number 2, we just have to differentiate the exponent functions and then differentiate the functions, the upper functions. Yeah, so it could be like if x and x equal to 5x squared minus x ln 5, because the basis is 5, and times with the differentiations of x squared minus x. So it could be like 2x minus 1. Yeah. And since if x and x is the same with dy dx will be equal to 5x squared minus x ln 5 times 2x minus 1. Next, what about if we have natural numbers as our basis? Actually, it's just come the same, yeah? So number 3, if we have y equal to 2ex plus e powered by minus 3x, what will the dy dx will be? Okay, remember for the table number 3, we see that y equal to ex is having the derivative form says y(n) equal to ex, yeah? So just the same, yeah? And we could also remember the addition rule. Dy dx of fx plus gx, it could be equal to dy dx of x plus dy dx gx, yeah, equal to dy dx of 2ex plus dy dx of e minus 3x. Okay. Differentiations form of 2ex will be still 2ex. And this one, we could also write e minus 3x, but we have to times it again by the differentiations form of the upper functions, that is minus 3. So if we simplify the functions, it could be 2ex minus 3e minus 3x. That's it. I hope my explanations are clear. Nice to see you. Have a nice day.